which is just a continuation. Part B is just a continuation. We're just going straight into this, right? Biochemistry. Okay? Biochemistry is the study of those chemicals, those reactions that occur in something that's living or biological, right? That's what that means. So when you study biochemistry, you study how those chemical reactions work in a living organism. Basically what that means. Now those reactions and those chemicals can be organic and inorganic. They can be a combination of those two. So what is inorganic? Anything that doesn't contain these two together. What does C stand for? Carbon. What does H stand for? Hydrogen. Okay? So it has to have at least one of both of these to consider itself organic. If it doesn't, it's inorganic. That's as simple as it is. I wrote 4 compounds there, okay? Let's talk about this one right here, water. Is water organic or inorganic? Why? It has hydrogen, but it lacks what? Doesn't have carbon. Right? Does that make sense? What about CO2 or carbon dioxide? Is that organic or inorganic? It's organic? You think it's organic? Okay. You think it's organic or inorganic?
Organic.
You think it's organic? Organic or inorganic? You don't know.
Inorganic.
Say inorganic. Is that a guess or that's like, I'm for sure?
I am saying because there's no hydrogen. There's no hydrogen.
It's inorganic because it doesn't have hydrogen, although it does have carbon. You see what I'm saying?
Yeah.
So that's, yeah, I mean, that one's a toughie, but she's absolutely correct, right? It has carbon, but it doesn't have hydrogen. It has to have one of both of them. That's the rule. So let's look at this one. This is actually the chemical formula for glucose here, C6H12O6. That's glucose molecule. And that one is organic or inorganic? That one for sure is organic, right? Has carbon and hydrogen, and actually it has 6 and 12. That's a lot of them. But it only needs just at least one of each. And this one, methane, is organic or inorganic? Inorganic? Organic, yeah. It's okay. It's got carbon and hydrogen. It's got 1 carbon and it's got 4 hydrogen, but it's got 1 of each. Does that make sense? Really easy to understand. I mean, once you go through that, that should be like, okay. Makes totally sense. Okay? So what are some examples of inorganic? We see some of those there, like water, right? Salt, NaCl. I should have put that one on there. That's inorganic for sure. Many of your acids and bases are inorganics, right? Your organics are usually your these, right? Carbohydrates, fats or lipids, proteins, nucleic acids. And in fact, all of those we use and we have in our body, right? Most of our food is composed of these, right? It's going to be a carb, a lipid, a protein. It's got nucleic acid in it, I'm sure, or a combination of that, right? Because if you eat a mixture of foods, which we do normally, I mean, if we go eat lunch, it's a mixture of that stuff. It's not like, just give me a steak and that's all I'm going to eat, mostly, right? I mean, we got bread there, we got veggies, and everything's got a good amount of fat. There's a mix of it. All right. Goes into detail, so I'll get through that, but I want you to read on that, right? Salts. It's an inorganic molecule, and I want you to read on your own why is it important. the second part, right? Call it electrolytes. What does it do? So right here. Right there, right? It's important for homeostasis, right? Talk about homeostasis. Plays a role in homeostasis. It's got roles in body functions like the nervous system. We use electrolytes to conduct the nervous system. That there. But I don't think we're going to go through much of that. We're going to kind of pass that point. Okay. Let me talk about this here really quick. Those organic molecules. And that's really what the rest of this PowerPoint is all about, is looking at each one of those and looking at the function. Okay? So what I want you to do, because we're running out of time here, and tomorrow I want to get into cells, right? So I don't want to bog us too far down anymore past this point in chemistry. But what I want you to do is make sure that you go through each one of those, which is on the PowerPoint, and know what the monomer is for each one of them, and the function of each carbohydrate, or each molecule, organic molecule that you see here. Monomer, and the function of each of these types of compounds. Okay. Now I'm just going to go really quick to define what a monomer is, and then look at the function really quick before we're done. Okay. We know that these organic molecules, like carbohydrates, proteins, fats, we call them polymers, which means there are a bunch of individual chemicals put together, right? But when we break them down, we can break them down to a simple organic compound that we call a monomer, right? And depending which one we're talking about, they're going to be different monomers for each one of them. We use those in the body, and the reason why I want you to know the monomers is because we use the monomer to build things for our body. Right? We call these monomers building blocks. Okay? Like this one right here, carbohydrate. The monosaccharides are the monomers. So if I put two monomers together, two monosaccharides, we call that a disaccharide. If I put two or more, or three or more, let's call that a polysaccharide. Carbohydrates contain carbon, hydrogen, and oxygen. The monomer that we usually concentrate on in a glucose molecule is that one, right? That's a monomer, right? Glucose, right? Blood sugar. We talked about blood sugar a little bit on yesterday. The day before. Okay? We don't need to look at the chemical structure of any of these. So don't worry about looking at the chemical structure, because you're not going to be given it, and say, okay, tell me what carbohydrate that is. Oh, that's ribose. No, we're not. That's for another class, right? But we're just going to look at, we just need to know what a monomer is. Glucose is a monomer, but these are also monomers there too, right? Fructose, galactose, so on and so forth. Does that make sense, right? So that's what I want you to pull, right? Monomer, its function, the elements it's made up of, that's it. Okay?